Hello everyone, welcome back to my channel. So here I'm going to read the Combustion and Flame of Class-8 Chapter 6 of CBSE. Let's start. Combustion and Flame. What happens when suddenly the electricity cuts at night? Most of the people light a candle immediately. It burns and gives out light. Now think of a moment. Would you get the same amount of light had you burned a piece of coal in place of the candle? What is the difference between the burning of a candle and the burning of a coal? It's the flame. There are many substances that burn with a flame and many others that do not burn with a flame. In this chapter, we shall learn about the chemical process of burning and the type of a flame produced during the process. What is combustion? The process in which a substance combines chemically with oxygen to give off heat and sometimes light also uh, is called combustion. As heat is energy, as heat is involved in this process, combustion is an exothermic process. The substance which burns readily is called combustible substance. It is also called a fuel. For example, petrol, diesel, LPG cooking gas, wax, kerosene, paper, cloth, wood, coal, etc. are combustible substances or fuels. The substances which do not burn are called non-combustible substances. For example, water, glass, sand, etc. are some non-combustible substances. Let us perform an activity to check whether a substance is combustible or non-combustible. Activity 1. To check whether a substance is combustible or not. Materials required. Different materials as matchstick, paper, wood, stone piece, charcoal, straw, glass, iron nails, etc. Procedure. Collect the materials mentioned above. Carefully try to burn all these materials one by one. Do all the materials burn equally? Mark the material that burns as combustible. Mark the material that does not burn as incombustible. Record your observation in the following table. Observation, property, materials. Conclusion. All substances do not burn equally. Note. Perform this activity only under the supervision of a teacher or elders. A substance which helps combustion or burning is called supporter or combustion. For example, when magnesium wire is burnt in air, it burns with a dazzling light. Here, oxygen or air is supporter of combustion. If the supply of supporter of combustion is cut off, the combustion or burning stops. This can be demonstrated through the activity. The following activity. Activity 2. To show that air is necessary for combustion to take place. Materials required: 2 candles, 2 glass jars, 2 wooden stands. Procedure. Fix 2 burning candles on the wooden stands. Cover one of the candles with a glass jar. Observe. Both of the candle. What do you see? Observation. The candle under the jar continues to burn for some time and then it gets extinguished, whereas the candles kept in the open continues burning. Conclusion. This happened because the supply of air oxygen to the candle under the jar is cut off. This activity shows that air is necessary for combustion. In other words, it is a supporter of combustion. This is the reason why a person whose clothes catch fire should be covered with a blanket. It is because the blanket cuts off the supply of air on the fire extinguished. Thus, without oxygen, even a combustible substance will not burn. Temperature is also an important condition of combustion to take place. Ignition temperature. Each combustible substance must be heated to a certain temperature before it can catch fire. The lowest temperature up to which a substance must be heated before it catches fire is called its ignition temperature. For example, a matchstick through combustible does not catch fire on its own at room temperature. It burns only after rubbing it on the side of matchbox. It means on rubbing the matchstick, its temperature reaches its ignition temperature. Ignition temperature is also called as uh, kindling temperature. The substance having low ignition temperature catches fire easily. Ignition temperature of a substance depends on its chemical nature. Ignition, the ignition temperature of petrol is lower than of kerosene. A low ignition temperature means the substance will catch fire quickly. It is the reason we need to take special care in storing petrol or diesel. A combustible substance cannot burn or catch fire as long as its temperature is lower than its ignition temperature. This can be shown through an interesting activity. Activity 3, to show that a combustible substance cannot burn below its ignition temperature. Materials required: water, candles, 2 sheets of paper for paper cups. Procedure: make 2 paper cups by folding the paper sheet. Pour about 50 ml of water in one of the cups. Carefully heat the cup separately with a candle. What do you observe? Observation: the empty paper cups burn rapidly while the water becomes hot in another cup. Note: perform this activity only under the supervision of your teachers or elders. In the above activity, the paper cut with water does not burn because the heat supplied to it is transferred to water by conduction. So the ignition temperature of paper is not reached in the presence of water. This is the reason that kerosene oil or wood do not catch fire on their own at room temperature. But if the kerosene oil is heated a little, it catches fire. Does the same happen with wood? Substances which catch fire at very low temperature and burn with flame are called inflammable substances. Remember this point. Substances which catch fire at very low temperature and burns with a flame is called inflammable substances. For example, LPG, petrol, spirits, kerosene, and inflammable substances are inflammable substances. Condition necessary for combustion. There are 3 necessary conditions for combustion to take place. Availability of fuel. Fuel is the substance that undergoes the combustion. For example, wood, charcoal, kerosene, etc. are fuels. Supply of air. Oxygen is a supporter of combustion. air with 21% oxygen helps the combustion. Without oxygen, combustion will not take place. Ignition temperature or heat. For catching fire, a combustion substance must reach to its ignition temperature. Combustion will not take place if the combustion will not take place if the combustible substance does not react or at or above its ignition temperature. In other words, it has to be heated to reach its ignition temperature. Thus, heat is also necessary for combustion to take place. These three, that is, fuel, oxygen, and heat, to reach ignition temperature, form a fire triangle. Putting out a fire involves breaking the fire triangle. That means removing neither the fuel or the air, oxygen, or the heat. How do we control fire? Many a time, homes, forests, shops, factories, etc., catch fire accidentally. In such cases, it is necessary to put off the fire, otherwise, it may cause a great loss of lives and property. For this purpose, a fire brigade or a fireman is called. A fire brigade or a fireman is called. They initiate the fire either by pouring water or using fire extinguisher. As we know that availability of fuel, supply of air, and ignition temperature are the three essential conditions for combustion. To extinguish fire, at least any one of these three essential conditions for combustion must be removed. In the case of fire in a building, if the fire spreads throughout the building, in the building it's not possible to cut off the supply of fuel. In such situation, firemen try to cut off the air supply or bring down the temperature of combustible materials below their ignition temperature. This is done by either using water or a fire extinguisher. Fire extinguisher. Water is one of the best, cheapest, and oldest fire extinguisher. By pouring water over the combustible material, the temperature can be brought down. Lower temperature or cooling down brings the combustible materials below their ignition temperature. In adding to this, water vapor surrounds the combustible material, which stop the supply of air. Removal of these two conditions put out the fire. This is the cause that firemen generally pour water over the materials which have caught fire. But water is not suitable in the case when electrical equipment or oil catches the fire. In the such case of electrical equipment on fire, pouring water over them may prove destroyers because normal water is good conductor of electricity. It may conduct electricity and can harm the persons who are trying to control the fire. In the case of fire due to oil and petrol, also water is not good extinguisher. Water is heavy than oil, so when water is poured over oil, oil comes on the top and keeps on burning. For such fires it is the best to use carbon dioxide as fire extinguisher. Carbon dioxide does not supply combustion. It is also heavier than air and hence covers the material which is burning. By covering the material, supply of oxygen is stopped. This puts off the further combustion and fire is controlled. Working of fire extinguisher. Under high pressure, carbon dioxide liquefies and takes less space because of compression. Liquid carbon dioxide is stored in cylinders. A nozzle attached with cylinder to release carbon dioxide. When nozzle is opened, carbon dioxide starts coming out from the cylinder because of high pressure. It expands and covers the combustion material as blanket. This cut off the supply of oxygen to the combustible material because of expansion. The temperature of carbon dioxide decrease, which decrease the temperature and brings down the combustible materials below their extinction temperature. Thus, the stoppage of supply of oxygen and bringing down the temperature below the ignition temperature of combustible materials put off the fire. Sodium bicarbonate or potassium bicarbonate can also be used as fire extinguisher. Sodium bicarbonate, baking soda, or potassium bicarbonate gives off carbon dioxide on heating. Thus, when powder of sodium bicarbonate or potassium bicarbonate is sprayed over or near the fire, they release the carbon dioxide, which converts the burning material that cut off the supply of oxygen to them. This puts out the fire. This is used specially to extinguish grease fire or fire due to oil. Types of combustion. Combustion can be divided into three types: rapid combustion, spontaneous combustion, and explosion. Rapid combustion. Combustion in which a substance burns rapidly and produces heat and flame is also known as rapid combustion. Such a combustion of natural gas, LPG, petrol, etc. This is usually attained by introducing external heat. Substances which undergo rapid combustion have lower extinguishing. Spon- Spontaneous combustion. When a substance suddenly starts burning into a flame without the supply of any external cause, such as heating, the combustion is called spontaneous combustion. Substances which have relatively low temperature of ignition generally burn by spontaneous combustion. Some examples of spontaneous combustion are illustrated below. Phosphorus and sulfur start burning instantaneously at room temperature. Haystacks, linseeds, oil, coal, pyrite, etc. sometimes starts burning suddenly with flame because of increase in temperature. In coal mines, fire breaks out of many times because of combustion of coal dust, leading to the death of many persons working in deep mines. Fire often breaks out suddenly in forests because of increase in temperature due to sun or friction. Explosion. Explosion. When combustion is accompanied by sudden production of heat, sound, and large amount of gas, it is called explosion. Firecrackers and bombs undergo explosion. Flame. When you light up a matchstick, it burns with a yellow flame. The flame produced by burning LPG is blue. The flame produced by kerosene when burnt a lamp is yellow and smoky. But when burnt in a stove is blue and smoke free. All gases combustible substances burning with a flame. Liquid combustible fuels are also burned with a flame. Solid combustible substances, when burned at a low temperature, do not give off a flame. At higher temperature, however, when solid combustible materials vaporize, these also burns with a flame. Thus, only those solid and liquid fuels which vaporize on heating burn with a flame. For example, kerosene, a liquid fuel, and wax, a solid fuel. Both vaporize on heating to burn a flame. A flame is the shining zone in which